We're going to do a torque curve PID adjustment. To start out, we set the P, I, and D controls to 0, and the PS, IS, DS scales to A. This is the lowest range, and these scales are like a coarse adjustment when the slider is a fine adjustment within that range. What I'm going to show right now is how to adjust the PIDs for a torque stabilized control, or a torque curve in this case. I'm going to load the motor during the test a maximum of 80 ounce inches. So I want to put the highest value in this control, high value, 80. The lowest torque is of course free run, so we put in 0 for that. The dwell is just the amount of time that the routine holds at the low value and then goes to the high value and holds there. So there will be 2 seconds at low value, 2 seconds at the high value. This gives us enough time to make our PID adjustments and see the system response. I am using a DC motor that has a power supply programmed from the MTest software. In this case, I'm setting the motor voltage to 10 volts. Each parameter, P, I, and D, have a slider which goes from 0 to 99, and a scale which goes from A through I. A is the lowest gain setting, I is the highest. Within each one of those settings, you can fine-tune by adjusting the slider from 0 to 99. Now, there's several ways of adjusting the slider. The first is place your cursor on the slider control, click your left mouse button, and drag it up and down. And you'll notice that the indicator at the top follows the setting of the slider, and there's also a digital indication to the right of the slider itself. You can also move the mouse to the approximate value and click the left mouse button once, and the slider will jump to that value. The third way of adjusting the slider is to double click in the window and type in a value. You'll need to take your mouse off of that control and click it elsewhere on the screen for the value to be entered in. On the range or the scale settings, A through I, you can use the up-down arrows to the left of the indicator and click on those to change. Or you can put your cursor in the window itself, click, and then drag down to the desired range, and then select it with another left click of the mouse. So to begin our adjustment, we need to put something in the P term. So we'll just put an arbitrary number of 50 in there. You see the slider comes up to 50. The slider is a fine-tuning adjustment within the scale that is selected by the PS, or the P scale control. What you'll see on the screen are 3 colored lines. The blue one is the control signal that we're sending down to our dynamometer controller. That will cycle between our low value and our high value. So you'll see a square wave, 2 seconds at low, 0, 2 seconds at the high value, 80. The green line is giving you a reference for our initial setting for the P term. This is 25% of our target value, which is the high. In this case, it would be 20 ounce inches. So the the goal here in the first part of the adjustment is to get the P term adjusted so that the system response is reaching 20 ounce inches. And the system response is indicated by the red line. So let's start running our motor at this time. And you see the 3 lines, the control going between 0 and 80, the 20 ounce inch green line, and then our system response, the red line. Now, since nothing is happening with the system response, we'll need to increase the P term. So let's go to the next range, B, and observe it for any changes. And there's no change, so the gain is still too low. So we switch to the next range, C, and still nothing happening. So go to the next D. Now you see we have some response, but not coming up anywhere near the green line. You can try using the P slider to bring it up to the green line, but at the maximum setting it still doesn't reach it. So we'll go back down to, say, our 50 and go to the next scale. So now on the E scale we're getting very close to our target, and we can probably adjust it in with the slider, and you'll see that we can do that. We've gone a little too far, a little bit under. It doesn't need to be exactly on that green line, but it is a good starting point for the control. Once we've achieved that, we need to focus on the I term. Now the I term is going to cause our system response to come up to our target value. What we're looking for is a fast response, and generally you get that by adjusting for a small amount of overshoot, but you also want it to become stable so it cannot oscillate much once it reaches that target. So again, we start with a number in the control. Let's put 50. And you see a little bit of action is happening, but not enough. So we go down and adjust the I scale from A to B and see what the result is. And we're getting more response, but still not enough to get to our target. So we go to the C scale, and it's better, but still not there. Go to the D scale. Now this one is eventually getting up to our target, but it's taking more than 2 seconds, and that's not good system response. So let's go to the next scale. Okay, now we're getting up to our target value, but it's taking about a second. So what we want to do is speed that up by increasing the I term. Okay, now we're getting fast response. It's overshooting a little, but it is coming and stabilizing at the target value. So at this point, we could say that the system is properly tuned, and we could continue on with our motor testing.